Okay, so in this video we will discuss the PT diagram. So you already know PV diagram, you already know TV diagram, and now we are going to discuss PT diagram. So here you see this is actually the PT diagram for a pure substance. So actually what happened, it has a unique characteristics if you compare this diagram with two other diagram. So you can remember two other diagram, it was like the temperature was a increasing trend, or it was a decreasing trend, like that. But it has a unique characteristics, like you will see here it has three different phases which is separated by three different lines. So this is solid phase, this is the vapor, and this is the liquid. And three different lines, you see this one, this line, and this line, they are just separating these three phases. So this solid, it is separated by this line and this line, liquid is separated by this and this line, and liquid vapor is separated by these three lines. So as the three phases are separated by three different lines, so we can say this is a phase diagram. Okay, so now the question is, what is this sublimation? Sublimation is actually some convergence process where the solid phase directly converts into the vapor phase, and it is actually called sublimation. So we call this line is sublimation line. So what happened if the solid actually convert into the vapor? So then what will happen? In general, you will see this diagram, it will actually show you the variation of the pressure and the temperature. So during the sublimation process, if we want to convert the solid into vapor, then what we need to do is we need to increase the pressure. So this is the pressure, you can see that upward direction. So if we take a point like this here and just draw a line, so you will see, let's say pressure P on here, the temperature is T on here. Let's say another point here, so it is this dotted line. So this is P2 and T2. So what we found here, definitely this P1, it is greater than P2, isn't it? The pressure P1 is greater than P2. That means if we increase the pressure, then, and here also you see T1 is greater than T2. So that means if we increase the pressure, then temperature will also increase. If we decrease the pressure, temperature will also decrease. That's actually the thing happens when the sublimation happens. That means the phase convergence happens from the solid to the vapor, from this solid to this vapor. So if we increase pressure, temperature will increase. If we decrease pressure, temperature will decrease. It's just proportional, and we will get a curve like this, an increasing trend. The same thing will happen for liquid to vapor state. So if when we consider the phase liquid, if we want to convert this liquid into vapor, then what we need the vaporization, or in other words you can say the boiling. Okay, the boiling. So vaporization or boiling. So in this case, actually the same thing, if you draw a point here, you can see the pressure. If you increase this pressure, the pressure here, it will be the temperature here. So if you increase the pressure, the temperature will increase. So let's say here, I can put it like this. So let's say here, but this pressure, temperature is this. If we increase pressure more, then you can see temperature will increase more. So the same thing we can say from the liquid phase to vapor phase. If we increase the pressure, temperature will increase during the boiling or the vaporization process. So the saturation pressure will increase with the saturation temperature. So that's proportional. So we understood actually what happens during sublimation and the vaporization or boiling. Now the other thing is what will happen from solid to liquid. So if we want to get the solid phase, and if we want to convert the solid phase into the liquid, then what we need is the process is the melting. So solid will melt, and let's consider ice. Okay, so if we consider that this example for ice, what will actually happen is for ice actually an increasing of the saturation pressure for ice. The temperature of this this melting, or the saturation temperature of the fusion, you can say this process is melting or fusion. Okay, fusion. I can maybe write it clearly here, fusion. So that's the process, melting or fusion, whatever it is. So from this solid phase to the liquid, actually you see with the increasing of the pressure, the temperature will decrease, and that's is the negative slope. It will give us a negative slope like this, and the temperature will, you see, decrease with the increase of the pressure. For better understanding, I can draw it like this. So let's say if we just select this point, so this is the pressure, you can see this is the temperature. If we decrease the pressure here, so this is the point here, so this is pressure is increasing down the upward direction, so it is less pressure here, but you will see the temperature will increase at this point. So that's actually the important thing, and it will give us a downward curve. So that's actually the physical phenomenon of pressure and temperature diagram. Now another important point is, what is this point? It says this is the critical point. That means at this point we'll get a there is no distinct phase. At this point, this is the critical point. You already know critical point, so here it is the we know the definition of the critical point, so I'm not going to discuss actually the definition of the critical point again, but I actually want to tell you the triple point. The triple point is the point where these three lines the coexist, kind of they coexist. That means they will, all of these 3 points, that means this vaporization or the boiling, melting or fusion or sublimation, these 3 point, this 3 line of the pure substance, let's say ice, they will coexist in equilibrium. And if it is the case, then we can say it is actually the critical point, triple point, sorry, this is the triple point. So in simple word, if 3 line, if they just coexist in an equilibrium point, then we can say this is critical point. So from this PT diagram, what we understood is actually how the saturated pressure and the relation between saturated pressure and the saturated temperature, and we found a similar characteristics for this sublimation and vaporization, but a different characteristics when it is melting or the fusion process. So we can see the pressure is increasing, temperature is decreasing. So that's actually the PT diagram. So that's it.